Hello and welcome to my video. Today we are going to calculate the following limit. So it says limit when h approaches 0 sine x plus h minus sine x over square root of x plus h minus square root of x. And here I will present you 4 methods of doing that. So let's get right on to it. In the first method, we are going to just straightforwardly calculate the limit by manipulating the functions at the numerator and the denominator a little bit. First, let us take a look at this sine x plus h part. Here we are going to apply the famous angle addition formula for sine. So in the numerator we have sine x cosine h plus cosine x sine h, then minus sine x. And for the denominator, we are going to rationalize the denominator by multiplying square root of x plus h plus square root of x at both numerator and denominator. So here the denominator simply becomes x plus h minus x, which is simply h. And in the numerator, we have sine x here and sine x here. So if we group those terms with sine x, we have sine x times cosine h minus 1 and cosine x sine h. Here we are going to use this famous and very important limit of trigonometric function. Limit of sine h over h when h approaches 0 is 1. Hence we must change the given expression so that this term appears. And we can do that by splitting the given fraction. So first let's write cosine h minus 1 over h first. Then we have times sine x. And for the second part, let us write sine h over h, then we have cosine x. So we have sine h over h right here. Now for this part, we have 0 over 0 form, so we change this fraction by multiplying cosine h plus 1 at both numerator and denominator. So we have this expression. Now, this part equals cosine square h minus 1, which is minus sine square h. So we have minus sine square h here. Now, for this part, we further split it into minus sine h over h times 1 over cosine h plus 1. Then we have one more sine h left. Then we have sine x. So now, this term approaches 1. And this term approaches 1 over 2, and this term approaches 0, and this term approaches 1, and this term approaches square root of x. Therefore, we have minus 1 times 1 over 2 times 0 times sine x plus 1 times cosine x times square root of x plus square root of x. So this entire term becomes 0. So we have 2 times square root of x cosine x. And this is the answer. Now let's move on to the second method. Here we are going to directly calculate the limit again, but this time we are going to use different trigonometric identity. Here we are going to use this formula, which is the useful formula to convert the difference into a product. There are actually total 4 of these formulas where you can convert the sum or difference into products. So using this formula on the numerator, we have 2 times cosine x plus h plus x over 2 sine x plus h minus x over 2. And for the square root part, we do the same rationalizing the denominator thing. So here we have already seen that the denominator becomes h, and in the numerator we have 2 times cosine x plus h over 2 and sine h over 2, then the square root part. Here, we are going to use this limit again, but here we have h over 2 instead of h, so we also need h over 2 at the denominator. Therefore, we send this 2 here into the denominator. So we have cosine x plus h over 2, then this part becomes sine h over 2 over h over 2, and the square root part. So now this term approaches cosine x, and this term approaches 1, and this term approaches square root of x. So we have cosine x times 1 times square root of x plus square root of x. Therefore, we have 2 times square root of x cosine x. So that was the second method. The third method is called using the definition of the derivative. Here, we are going to use the fact that the derivative of function fx is defined as limit when h approaches 0, fx plus h minus fx over h. So what we do here is dividing both numerator and denominator with h to obtain this expression. And we can split the limit like this if both of these limits converge. Well, do they? Yes, they do, because both of them takes the form of the definition of the derivative. So the numerator is the derivative of sine x, and the denominator is the derivative of square root of x. The derivative of sine x is cosine x, and the derivative of square root of x is 1 over 2 times the square root of x. So we have 2 square root of x cosine x, which is exactly the answer we've obtained in previous two methods. Alright, now the last method, and this one easily earns the title, the most savage method. Notice that as h approaches 0, both the numerator and the denominator approach 0, which means that this is 0 over 0 type of limit. Therefore, by this L'Hopital's rule, this limit is equal to the derivative of the numerator, and actually the derivative with respect to h, over the derivative of the denominator, also the derivative with respect to h. If we differentiate each part with respect to h, in the numerator we have cosine x plus h, and in the denominator we have 1 over 2 times square root of x plus h. And now if we send h to 0, we obtain 2 times square root of x cosine x, which is of course the same answer that we've already obtained. And that's all for today's video. Thank you for watching, and I will see you in another video.